Let's continue talking about really accurate 8-foot rip cuts with a track saw. The comments I got on my previous video were great and surprising. The part I'll call great is that the comments were really positive. People seemed to enjoy the topic, and a number of people posted comments with interesting and helpful suggestions about the technique I was using. And the surprising part of the comments is that only a few people said I was crazy. And those of you who did say I was crazy, I mean, y'all said it nicely. I don't know that anybody actually used the word crazy or worse. And I might have deserved it if you did. I mean, I'm doing an 8-foot rip cut and I'm complaining about an error that's less than a 64th of an inch. The internet brings out the worst in everyone. I expected folks to claim that my parents were brother and sister. So I would say the comments on my last video were a remarkable example of civility and good manners on YouTube. I'll just admit that whether you all think I'm crazy isn't really the most interesting thing to me. I'm gonna carry on with this until either my tools or the wood tell me I'm crazy. Until I find a good reason why not, I think I should be able to use a track saw to get a cut that is as straight as the rail that the track saw is riding on. Obviously, if the rail is not straight, I'm not gonna end up with a straight cut, and we covered that. So if the rail is straight, then I'm hoping everything else is a matter of technique. My approach to this problem is to figure out everything that might go wrong, and for each item on that list, hopefully there's a remedy. Obviously, one thing that might go wrong is that the rail is moving when it's not supposed to be. To get accurate rip cuts, we need a way to make sure the rail isn't moving. In my case, I'm using the dashboard system, so I have a spiral dog that goes under the rail and it mounts into a track star on the end of the bench. There's lots of other solutions to this problem depending on what kind of MFT setup you have. One way or another, the rail needs to not be moving. In order for the track saw to accurately follow the guide rail, it needs to follow the guide rail, and that means that this adjustment here needs to be correct. This is something that deserves to be on the checklist. Is there any play between the saw and the guide rail? One thing that often gets mentioned as a possible source of problems is the question of whether the blade can flex or deflect because it's thin. I use a Festool TS 60 track saw, and the blades for this saw are all 1.8 millimeter thin kerf blades. In contrast, this is a blade for a TS 75 track saw, and this blade is considerably thicker. I'll be happy to admit that in theory, a thinner blade is more likely to flex than a thicker blade. The question is, what would cause the blade to flex or deflect? Intuitively, if the blade is flexing or deflecting during the cut, it's because some pressure perpendicular to the surface of the blade caused that. And as I explain further, you'll see that I have other reasons to try to avoid that kind of pressure. Now, perhaps I'm wrong. Maybe the blade will flex for no reason. I don't think that's likely. And because there would be no remedy for it, I'm going to ignore that issue for now. But what makes sense to me is that the notion of straight is a one-dimensional concept. The only thing that should be changing position in this cut is the saw, and its position should only be changing in this direction, one-dimensional. I think our enemy here is anything in the other dimension, this dimension. Any force or pressure that causes the saw to deviate from its one-dimensional mission seems like a bad thing for accuracy. So for example, we need to make sure that the saw doesn't wobble. As I hold the handle and apply pressure side to side, you can see the track and the saw moving. Granted, I'm exaggerating this by doing it on purpose and because there's no board under the track right now, so there's no support. But I think you can see the potential for this to cause accuracy problems. So we checked our guide rail and we found out that it's straight. Now the question is, does it stay straight? I mean, this thing's aluminum. What are the chances that it could bend or flex a little bit, especially when we're moving that heavy track saw across it? So I've rigged up a dial indicator and zeroed it. And standing over on this side of the rail where I would be standing while making the cut, I'm going to apply just a little bit of pressure. There's no question that it can flex a little bit. I don't want to get out of hand with this, but when I push a little bit harder, I can get pretty close to 10 thou of deflection, which is 1/100 of an inch, which is kind of the standard that I've had in mind as I seek accuracy in this situation. To reduce the chances of introducing a side-to-side error, I'm going to do these test cuts without outriggers in place on my dashboard setup so that I don't have to step around them while I'm moving the track saw down the rail. It seems to me that if I make sure everything that's not supposed to move is not moving, and the track saw is only moving in one dimension, and I eliminate all the side-to-side problems, then I should be able to get pretty straight cuts. That's what I want to test. And the first way I want to test that theory is to mess it up intentionally. I'm going to do a cut where I'm leaning the track saw like a race car driver going around a sharp curve. What I should get is an edge that isn't straight. Oh yeah, this is very nice. This is every bit as dreadful as I hoped it would be. Okay, so let's try a cut where I try and do it right. I've got the far end of the rail dropped into the track star. I'm going to drop in this side, and then I'm going to, just to make sure that I haven't accidentally flexed the track, I'm going to lift up a little bit and let it back down here. I'm just going to check the track here at a couple of points. So for this cut, I'm going to try and make sure that I have no lateral pressure or movement. I'm going to have the saw, as much as I can, go straight forward. So I can barely slip a 1/100 of an inch feeler gauge in the center there. Little bit of a gap there. No problems down here. So I made 4 attempts to do a rip cut with no lateral movement. And I think in general I got better results, but still not at the level I was hoping for. Are my tools telling me I'm crazy or that I'm expecting too much? Maybe. This is one of the plywood beams that I made. I'm using this to construct a reference surface. The edge of this beam is what I'll call really straight. I've checked it with the precision straight edge and a feeler gauge all along its length. The feeler gauge was 1/100 of an inch, and I can't find a problem. I checked it by laying it against this track saw rail using the same feeler gauge, and I can't find a problem. And I'm checking it now using a taut string with spacers and a feeler gauge, and I don't see a problem. This is the kind of result that I'm trying to get with a track saw, but that's not how I made this beam. The way I got this edge as straight as I did is I ran it through a jointer. Admittedly, putting plywood edges through a jointer is not generally a recommended technique. However, part of the reason for that is because traditionally jointers use steel knives, and those steel knives dull easily when they are subjected to the very hard glue that is used to make plywood. But in general, people don't worry about running plywood through their table saw. Why is that? Well, one reason is because table saw blades are a lot easier to deal with than jointer knives. But the other main reason is that table saw blades have carbide tips. And carbide stands up to plywood resin glue way better. My jointer doesn't have high-speed steel knives, it has carbide inserts. So I figure I should have little reason to protect the carbide in my jointer any more than I protect the carbide in other kinds of tools. So I ran this through the jointer and I got a really straight result. I just gotta stop for a minute and talk a little bit about what straight and flat mean. I have shot hours of video of me rambling on about the meaning of straight and flat in a wood shop, and I've never posted most of it because I didn't want anybody to find out that I'm crazy. But let me go ahead and say just a little bit about what these terms mean. First of all, one definition of straight and flat is based on math. And I always end up there because I'm a nerd. And this is the definition that goes something like all points on the same line. Or in the case of flat, all points in the same plane. This is a concept that exists only in theory. In the real world, if we were to use that definition of straight or flat, nothing is straight or flat. If you look at any surface closely enough, there will be mountains and valleys. You might need an electron microscope to find those mountains and valleys, but they are there. Which brings me to a second definition that I think is worth mentioning, which is something could be so flat or so straight that we lack the ability to measure how it is not. In the real world, this is something we could refer to as a form of perfection. If we can't discern, measure, or observe any problems with straightness or flatness, then in a practical sense, it's perfect, right? Which brings me to a third definition, which I think is useful, and this is a concept that I would call straight enough or flat enough. This comes up a lot when people in my comments think I'm crazy, because the simple fact is there's a lot of cases where we just don't need the kind of precision or accuracy that I'm exploring here. Different situations do have different tolerances or different levels of acceptable error. Usually in a woodshop, when we use terms like dead flat, we're implicitly referring to the notion of flat enough. So this beam has one pretty darn straight edge. The question now is, can I use a track saw to rip the other edge parallel and straight to the first one? I've got my dashboard rip gauge set just a little bit less than the current width of the board. I have my parallel guides set up and dialed in and double checked them both with a caliper. So I have the beam in place under the rail, and now what I want to do is take these spacer blocks, these are support blocks that happen to be the same size as the beam I'm cutting, and I want to place these under the rail to give the rail support during the cut. But I'm also going to use these 3 blocks as places to put a little bit of clamping pressure down to hold the rail in place. The beam is in place, the rail is in place, the rail is supported, and the rail has clamps to hold it in place. Now I'm going to double check and see if the rail is still straight. I can't find any problems with the rail in terms of it deflecting or flexing. So to the best of my knowledge, I think this setup is ready to try the cut. I can detect basically no problems with the .01 feeler gauge using the 50-inch precision straight edge and using the rail itself as a straight edge. I also did measurements at 7 places along the board, and in millimeters, these are 147.01, 146.9, 147.01, 147.09, 146.97, 146.80, and 146.81. These are the best results I've gotten with a track saw so far. Going back to the definitions of straight and flat that I mentioned earlier, one of the definitions was so straight that I can't detect any problems. I can't meet that definition, but I couldn't meet it with my cabinet saw or my jointer either. The next definition was straight enough, and that's a subjective evaluation that depends on the context and the situation. Certainly the results I'm seeing are straight enough for a lot of cases, probably for the cases that I'm considering myself. I don't have any immediate plans for a next video on this topic because I'm not sure what the next step would be. But let's not be surprised if I come back to the issue again if I find another technique to improve things even further.